Good morning, everyone. Board is visible.
Yes, sir.
Okay. So we already completed reaction mechanism and GOC. So keep on revising both the chapters. And after 2 weeks, again we will back to organic. But in these 7 to 8 or maximum 10 lecture, like 2 lecture in this week and 2 more weeks. So around 10 lecture, we are going to study basic inorganic chemistry. So I am just giving you idea what we will do. So we will do reaction part or the understanding part which can be understood in basic inorganic chemistry. So like part 1 is heating effect. Part 2 will be hydrolysis reaction. Part 3 can be acid base reaction. Okay. Part 4 will be redox reaction. Part 5 will be precipitation reaction. And part 6, complex formation. Okay. And part 7, mixed reaction. Like more than one concept can be here. Okay. So when we will complete these reaction specifically, so all the reaction in S block, P block, D block, F block, basically in block chemistry and salt analysis. Okay. Or qualitative analysis. All chemical reactions will be covered. Okay. So if we will pick any one of the reaction, the concept inside that particular reaction will be from this only, because reaction cannot be any other type other than these six. Okay. Yes, it is possible in mixed reaction that redox and precipitation simultaneously happening. Okay. But reaction cannot be more than these six type of reaction. Every reaction will have the concept of either heating effect or hydrolysis or acid base or redox or so basically in coming 2 weeks our target is to complete these reaction. Then I will share you notes of SPDF. So you just pick any one of the reaction and you can correlate with the concept. Okay. So this is our activity for next 2 weeks. It is understood to everyone.
Yes.
Yes.
So can I drop this or you want to note it down?
Sir, please wait.
So,
Done.
And obviously we have to learn all the reactions. So we will try to find out concept. Okay. If there is no concept, then we will learn how we can memorize it. Okay. So we will start part 1 heating. So in this first subtopic is heating of carbonate and bicarbonate. Yes or no?
Yes.
I think we already discussed this thing. Just I am writing for carbonate, there can be 3 categories, correct? Category A, category B, and category C. Okay. In category A, lithium, sorry, sodium, potassium, rubidium, and cesium. Basically, all alkali metal except lithium. Is this correct?
Yes.
And in category C, copper metal. Copper metals like Hg, Ag, Pt, and U metal. Okay, correct. So Hg2 2 plus, Hg2 plus, Ag, Pt, okay, gold. Correct. And in category B, rest all metal except category A and category C. Got it?
Yes.
So in category A, metal carbonate on gently heating, ideally no effect. In category 2, on heating, we will get metal oxide plus CO2, correct? In category C, we will get metal plus oxygen plus CO2 because from Illingworm diagram, these metal metal oxide of Hapa metal are thermodynamically unstable, so it will decompose to metal plus oxygen. Got it?
Yes.
We already discussed this thing. Yes or no?
Yes.
Okay, so this is all about carbonate. Now, what I communicated in bicarbonate, if we talk about bicarbonate, okay. So for heating of carbonate, we need to remember these 3 lines, and in bicarbonate, all metal bicarbonate will produce carbonate, H2O, and CO2. Okay, metal carbonate, water, and CO2. on heating, correct? So category A, category B, or category C. Okay. If we are having metal bicarbonate, then on heating, it will give metal carbonate along with H2O, along with CO2. And metal carbonate can be further divided into three parts on further heating. Category A, category B, category C. In category A, no effect. In category B, metal oxide plus CO2. In category C, metal plus oxygen plus CO2. Understood?
Yes.
So you just note down. These are first two sections. Completed this one.
Yes.
Acha, you need to remember one thing very carefully. Uh, in coming next 2 weeks, whether we are having lecture or not, okay, you have to revise all the notes from this part up to where we completed. Suppose in first lecture we completed heating effect. So daily you have to revise heating effect. Daily. Daily means daily without gap. Okay. And tomorrow we will complete, let's say, hydrolysis. So tomorrow onward you will revise hydrolysis as well as heating effect. So up to these 6 to 7 reactions, we have to revise all the reaction daily. So what will happen? We will have uh, we will have all type of reactions in our head, and we will be able to apply all the concepts simultaneously, because in S block we will get all type of reaction, in P block in every family we will get all type of reaction. So this is very important thing. If you want to upgrade your inorganic chemistry, then I will tell you the key pointer. but you have to be very clear that what is the key pointer and what we need to remember, and daily revision is compulsory. Okay, so this is very important point. I shared it in the starting. Keep on revising. You have to keep all the key pointers in your head. Then we will apply simultaneously in all chapters. Got it? Now, if we are having key pointers, this question is very easy. First is butanol and it is CO3. So it is a carbonate from category A, no effect. It is a carbonate from category B, so metal oxide plus CO2. It is a carbonate from category C, so we will have metal plus oxygen plus CO2, correct? And it is a carbonate from category C, again metal plus oxygen plus CO2. Now we are having category from carbonate from category B, metal oxide plus CO2. Now bicarbonate from category B, so we will have magnesium carbonate plus H2 plus CO2, but on further heating, it is a category B carbonate, so metal oxide plus CO2. Category C, initially we will have metal carbonate plus H2 plus CO2, but category C metal carbonate, we will have metal plus oxygen plus CO2. And this is category B, so Li2CO3 plus H2 plus CO2. In category B, we will have metal oxide plus CO2. Cesium, again category A, metal carbonate plus H2O plus CO2. And in category A, no effect. Got it? Zinc, ZnCO3 plus H2 plus CO2. Now we will have ZnO plus CO2 plus H2. Got it? Is there any doubt in this particular section?
No.
Completed?
1 minute. Done.
Okay. Next is next section is heating of nitrate. Okay, heating of nitrate. So again, we can divide into three categories: category A, category B, and category C. And fortunately, we are having same metal ions. Observation is this: like in category 1, okay, same metal ion, all metals except lithium. Okay, all metals except category A and C. And here alpha metal. Got it? So in the heating of nitrate, the categorization is same. Okay. Got it?
Yes.
Now listen, key pointer. If we are having from category 1, okay, so we will have MnO3 type. What we will get? We will get nitrite plus oxygen, okay, on gentle heating. Metal nitrate will produce metal nitrite on heating, okay. In category B, will receive metal oxide along with NO2, along with O2, okay. And in category C, metal oxide will decompose to metal plus oxygen along with NO2, and O2 is already there. Okay, so now no need to write O2 again. Got it? So in category A, we will have on heating metal nitrate, we will receive metal nitrite along with oxygen. So in all three categorization, whenever you heat metal nitrate, definitely you will receive oxygen as one of the gaseous products. But we will not receive NO2 gas. NO2 is a reddish brown gas. Will not receive in category A, but yes, in category B and category C, we will have NO2 gas as one of the product. And as usual, in category B, metal oxide, and in category C, metal plus oxygen. Got it?
Yes.
So these are the key points, okay? Now there is one very famous reaction. If you remember, please let me know. NaNO3 on strongly heating. This is a special reaction. When it is mentioned strongly heating, you know what will be the product. Can you find out from Google or from any book. You just search, everyone just search what will be the product on strongly heating an energy.
Sir, we will get the metal oxide, we will get sodium oxide, and we would also get the nitrogen gas.
Yeah, and one more product.
Oxygen.
There is one more product. Identify that product.
Sir, it would be oxygen.
Yeah. So just remember, this will give a special reaction, metal oxide along with nitrogen along with oxygen. Okay. But we will write these product only when it is mentioned strongly heating. Otherwise, we will treat gentle heating. Okay.
Yes.
Okay. So, what is the key pointer? These are the key pointer. Okay. After noted down, please complete these reactions. These are 8 reactions. These are visible on the board. These are in the frame.
Yes.
Okay. In first reaction, category A, we will have NaNO2 plus oxygen. In a strongly heated metal oxide plus N2 plus O2. And in category B, the metal oxide plus NO2 plus O2. Metal oxide plus NO2 plus O2. Metal plus NO2 plus O2. Hg plus NO2 plus O2. ZNO plus NO2 plus O2. KNO3, KNO2 plus O2. Got it? Is there any doubt in this particular section?
No.
There is one special reaction. If we heat particularly at 125 degrees centigrade, okay? What will be the product? See, if it is given, what will happen on normal heating, okay? Normal gentle heating, then we know the product, okay? Correct? But if it is specified heat only up to 125 degrees centigrade, then what will be the product? This can be asked. So just remember one liner. At 25 degrees centigrade, only 25% decomposition observed. Okay. So what will happen? 4BeNO3 whole twice on heating. So basically we are having 4Be. So we will have 4Be. Okay. And out of 4, 1Be will convert to BeO. So we can write BeO dot BeNO3 whole thrice and BeNO3 whole twice, and this will be 3. Got it? Got it? Hello? Hello?
Yes, got it.
Got it the key point? At 125 degrees centigrade, only 25% beryllium nitrate will decompose. So out of 4 molecule, only 1 molecule will decompose, and we will have compound like this. Am I audible?
Yes.
Okay, so you just note down this is the compound. And this is very normal compound. This is the combination of BeO dot 3 BeNO3 whole twice. Okay. Completed this part?
Sir, 1 minute. Yes.
Okay. Now, next section is heating of ammonium salt. Okay. So again, I will divide into two parts, category A and category B. Okay. So key pointer for ammonium salt. First point, if anion is non-oxidizing in nature, okay, like sulfate, carbonate, bicarbonate, chloride, sulfide, okay, non-oxidizing, like oxalate. Oxalate is non-oxidizing. Phosphate, okay, sulfate, carbonate, bicarbonate, chloride, sulfide, oxalate, phosphate, okay. So basically the anion which is not having any oxidizing nature, okay. If anion is having oxidizing nature, okay. If anion is having oxidizing nature, for example, we know Cr2O7 2 minus, correct? Iodate ion, perchlorate ion, perchlorate, okay, like nitrite ion, nitrate ion. Got it?
Yes.
So what we need to remember, if we are having non-oxidizing anion, then ammonia will be liberated. Okay. So this is the key point. And if we are having oxidizing nature, if anion is having oxidizing nature, then liberated ammonia will be converted to N2 or N2O. N2 or N2O will be liberated. And this thing is logical, okay? In ammonium salt, ammonia should be liberated, correct? But if your anion is oxidizing in nature, then ammonia, the liberated ammonia will become either nitrogen or N2O. Got it? So this is the key pointer we need to remember. Okay. Now we will apply these key pointers in the questions. Completed. So anion is non-oxidizing, then automatically it will produce ammonia. Okay, and if anion is having oxidizing nature, then it will further ammonia will be oxidized to nitrogen or N2. Got it?
Yes.
Now attempt these 11 questions. Okay, so in these six, you can check anion is non-oxidizing, correct?
Yes.
So what will happen? We will write ammonia, then we can check HCl will be the other product. Here, ammonia plus H2CO3, or we can write H2O plus CO2. Okay. Here, ammonia plus we can write H2SO4 as well as H2O plus SO3. Okay. It depends on this temperature. Okay. Here, ammonia plus H3PO4, or H3PO4 we can write H2O plus P2O5. We can write oxy acid here, or oxide of oxy acid. Okay. And here we will have two ammonia, and we will have H2C2O4, H2C24, H2O plus CO plus CO. Okay. H2C2O4 auxiliary will give oxide, CO and CO2. Here two ammonia plus H2S. Got it? So just check. Here we separate out ammonia, then HCl is remaining. Okay. Here we separate out two ammonia, then H2CO3 will be remaining. So H2CO3 we can write H2O plus CO2. Okay. Here two ammonia, then H2SO4. H2SO4 we can write H2O plus SO3 or heating. Here three ammonia, then H3PO4, and H3PO4 anhydride of H3PO4 is P2O5. Here two ammonia plus H2C2O4. H2C2O4 is H2O plus CO plus CO2. Got it? H2C2O3 on heating, we can get H2O plus CO2, correct? H2SO4 on heating, we can get H2O plus SO3. H3PO4, H2O plus P2O4. Got it? H2C2O4, H2O plus CO plus CO. Understood this point? Hello.
Yes.
Okay. So if anion is non-oxidizing, then this reaction is extremely easy. Okay, ammonia will be the product. Ammonia will be the product. Now, in these three reactions and these two reactions, anion is oxidizing. Okay, in nature, anion is oxidizing in nature. Okay, got it? Now, how we will proceed? Just listen carefully. Whenever we are having situation like this, we know either nitrogen or nitrogen monoxide will be formed. Okay. So what we will do, you just try to see this compound and just think how many maximum, how many moles of water molecule can be liberated. So yes, we can have 4 water molecules. Is this correct? Because per molecule we are having 8 hydrogen.
Yes.
So just write down the maximum water which you can remove. Okay. Now, chromium is in +6. When chromium is in +6, it is oxidizing in nature, correct? Then chromium will go in +3 after doing oxidation of ammonia, correct? So it will go in +3. So +3 compound will be Cr2. Got it? Hello.
Yes.
Because dichromate ion will react as an oxidizing agent, no? So dichromate ion, what happens when dichromate ion Cr2O7 in acidic medium, what happens? Cr3 plus, correct? Now just check what is remaining here. N2 only. Okay. So maximum 4 water can be liberated. Cr2O3 will be one of the product. Then automatically nitrogen is remaining. Got it?
Yes.
Now from this, from 1 mole of NH4NO2, how many moles of H2O can be liberated? 2. Okay. Then what will be the product? The remaining is N2 only. Got it?
Yes.
Is it clear to everyone
Yes.
how I am writing these reactions? Now, how many water can be liberated? 2H2O. Now, what is the remaining product? What is remaining? 2 nitrogen and 1 oxygen. Yes, N2O can be liberated. Got it? Hello.
Yes.
So whenever iodine and chlorine is there, just remember we have to start from 2 mole because final product will be I2 and chlorine. Got it? So from 2 moles, how many water can be liberated? 4H2O. Here, 4H2O. Got it? And listen carefully. If anion is oxidizing in nature, then we will have either nitrogen or N2O, and only in one compound we will have N2O. It means in all other cases we will receive nitrogen. Correct? So here we will receive nitrogen. Here we will receive nitrogen and oxygen. You can count, I guess, 1O2 and here 2O2. Got it? Hello. So if anion is oxidizing in nature, okay, in only one compound, we will get N2O, जो कि laughing gas होता है, मालूम है नहीं? only in one compound. Rest in all other compounds, okay, we will get N2. Okay. Hello. Hello. Is this clear to everyone? What is the key point?
Yes.
So you have to memorize in the same way. So
So what did you write in what did you write to the left of the X and the XI? You wrote like a curly bracket and you said in something.
no, here.
No, no, no. Towards right. Yes.
No, whenever we are having, no, this is just writing this extension of this. Anion is oxidizing in nature.
Okay.
This. Actually, these two reactions should be here, okay?
Okay, sir.
So anion is in oxidizing nature. See, this is very beautiful reaction. Ammonia is basic gas, okay? CO is neutral gas, and CO2 is acidic gas. Okay, got it? Basic gas, neutral gas, and acidic gas. All three gases, basic, neutral, and acidic gases, are producing on heated ammonium oxidate. Okay, this is the only compound in which we are receiving acidic, neutral, and basic gas. Okay. Hello. Hello. Am I audible?
Yes.
Sir,
Yes.
the bottom right corner, does that statement mean that only NH4NO3 on heating gives N2 and rest gives N2, like in oxidizing anions?
Yeah. Rest all if anion is oxidizing in nature. See, I have taken five reactions. If anion is oxidizing in nature, okay. In every reaction, we are receiving N2 as one of the product. Only we are getting N2 in only one product, one reaction. So NH4NO3 will give N2O, rest all will give N2 as the one of the things. Okay.
Okay, sir.
If
So
anion oxidizing in nature, only in one compound we will get N2O, laughing gas, and rest in all other compounds we will get N2. Got it?
yes, sir.
So completed. Can we move to next section?
Yes.
This is section number 6 or 5. Carbonate, bicarbonate, nitrate, ammonium. Okay. This is fifth. Heating of halide salt. Okay.
Sir, this is the fourth section.
Okay. So if carbonate and bicarbonate is one, then this is four. Okay. PbCl4 on heating. PbBr4 on heating. PbI4 on heating. Okay. AuCl3 on heating. AuCl3. FeCl3. G2Cl2 on heating. PbCN4 on heating. PbSCN all four on heating. Okay. AuCN3 on heating. FeCN3 on heating. Halide or pseudo halide. You know what is pseudo halide? Okay, just try to write down the answer. We will discuss it. See, listen carefully. Chloride, fluoride, bromide, or iodide. Okay, these are halides, correct? But cyanide and SCN minus are pseudo halide. Is this clear? Why these are pseudo halide? In reality, these are not halide, but the properties of these two anions are similar to like Cl2, F2, Br2, and I2. These are halogens and halide. These are known as cyanogens, if you know. This is thiocyanogen. Okay. So cyanide and thiocyanate exist as dimer form. Okay. This is known as cyanogen gas, cyanogen, and this is thiocyanogen gas. So the properties of cyanide and thiocyanate are similar to halide. Okay, that's why we are saying these two anions as pseudo halide. Is this clear? Is this clear to everyone?
Yes.
Okay. So now here we are having Pb plus 4. From inert pair effect, we know that Pb4 plus is unstable and it will try to convert into Pb2 plus, and the same is happening here. We will have PbCl2 along with chlorine. Okay. So here chloride ion is oxidizing and lead is reducing. So this is the reaction of redox plus heating. Okay. Okay. Here PbBr2 plus Br2 and PbI4 does not exist. So even at room temperature, it will convert PbI2 plus I2. Even heating is not required. Okay. Is this okay? Here AuCl plus Al plus Cl2, here FeCl2 plus Cl2, okay? Plus 3 is going into plus 1, here plus 3 is going into plus 2, here plus 4 plus 2, plus 4 plus 2, plus 4 plus 2, okay? Here plus 4 plus 2, plus 4 plus 2, plus 3 plus 1, okay? Plus 3, got it? Hello. So lead is going into plus 2, Fe is going into plus 2, okay? And gold is going into plus 1. Is this clear to everyone? Hello.
Yes.
Now this is a special reaction. This is ideally plus 1. It will go to 0, but it is going in this. Okay, plus 2 and 0. This is a special reaction. Rest in all other reaction, what is happening? Halide or pseudo halide will oxidize and other metal ion will reduce. Okay, but here disproportionation reaction. Mercury is oxidizing, mercury is reducing. There is no change in halide. So we will say this reaction is special. Okay, this is out of the trend reaction. Just note down. If you are having any doubt or you are not getting key pointer for this particular question, then let me know. The key pointer is clear because gold, iron, lead from higher oxidation state to lower oxidation state, and halide and halogen, pseudo halide, will convert to pseudohalogen or halide will convert to halogen, except one compound, Hg2Cl2. Got it? Completed this section. Is there any doubt?
No.
Okay. Now we will move to next section. Heating effect on hydrated chloride salt. You understood the concept of pseudohalide? Why these are called pseudohalide? Because these are having similar properties like halogen. Okay. These exist in halide form, similar to pseudohalide, and halogen, similar to pseudohalogen. Got it?
Yes.
And these are the only reaction which can be asked in this particular section. because these are the reactions which is given in NCRT as well as in JDD. Okay, so we will apply these concept only in these reaction. Okay. Next heading is heating effect on hydrated halide salt. So these are only 6 elements which will have similar reaction. Okay. So we can write Fe3 plus, aluminum 3 plus, Mg2 plus, CO2 plus, Zn2 plus, Sn2 plus. Okay. We will have metal oxide plus HCl plus water. Okay. Rest in all other, water will be liberated and anhydrous metal halide will be formed. Okay. But here magnesium oxide plus 2HCl plus 5H2O. Here Fe2O3, okay, 6HCl, now 9 water of crystallization. Here Al2O3 plus 6HCl plus out of 12, 6, 3H2O is already used, so we will have 9. Here CuO, here ZnO, here SnO, along with 2HCl, along with 2HCl, along with 2HCl, okay? And we will receive only 1 water of crystallization out of 2. Got it? So if we are having hydrated halide of these 6 metals ion, then we will have metal oxide plus HCl plus H2O. Rest in all other hydrated chloride salt on heating, we will get anhydrous salt along with water of crystallization. Anhydrous chloride salt. Okay, and full water of crystallization. Got it? We can see this reaction COCl2 dot 6H2 on heating 50 degrees centigrade. We will receive COCl2 dot 4H2 on 58 degrees centigrade. COCl2 dot 2H2 on 140 degrees centigrade. COCl2 plus 2H2. Okay, got it? The color of this compound is pink. This is also pink. and this is red violet, and this is blue. Okay. So see, cobalt 2 plus is not in the given category. Okay. So we can categorize into two parts. If metal ion is this, then we will have metal oxide. You can say these metals are having high affection for oxygen, okay? And HCl will be liberated entropically. But in all other sections, all other metal, uh, like COCl2.6H2, it will lose 6 water of crystallization, and final product will be COCl2, which is in blue color. And this is asked in JE that there is one chloride, hydrated chloride, which is pink colored on heating step by step. Further, we got blue colored anhydrous salt. Identify the composition of blue color and hydrated salt. Okay. So in any other halide which is hydrated, we will have full water of crystallization along with metal chloride. But in these six, we will have metal oxide, HCl, and water. Got it? So, Shaurya, you please repeat all the 5 key pointers of today's session.
So in heating effect of the carbonated ion, there we can classify metals into like 3 categories. Category 1 consisting of all all alkali metals except for lithium. They don't give any reaction upon heating the carbonate salt. Then category C, we can classify as hypermetals, Hg, and Au. Upon heating, they yield the metals and the oxygen and carbon dioxide. Rest of the other metals on heating gives us metal oxides plus CO2. And that's for the carbonate section. Then for bicarbonate section, all metals on heating will give CO3 anion, like carbonate anion, plus H2O plus CO2. And that's and then for NO and then for the nitrate case, again we can like classify into 3 categories. So category 1, upon heating gives us MnO2 plus half O2. Category B gives us Category B consists of all metals except category A and C. Upon heating, they give us MO plus NO2 plus O2. Category C are the helper metals again, and upon heating, they give metal plus oxygen plus nitrogen dioxide. One important reaction is NaNO3 upon strong heating gives us Na2O plus N2 plus O2. And another important reaction is BeNO3 twice heated at 125 degrees gives us Ba4O NO36. And then if we move on to heating of
Hello.
Yes,
Hello.
sir, I something was stuck in my throat. Can you please ask someone else to continue?
Hello. Hello. Am I audible? Hello.
Yes.
Am I audible?
Yes.
Yes.
Okay. So, okay. So we will continue in next class from here.